Hey, Matt.
Hey, how's it going?
Yeah, good. It's a little bit windy here today again this week, so hopefully we don't get too many interruptions.
Yeah, I know. I'm going to get it in about an hour, so I think I'm going to be lucky, but we might get a bit of feedback from your side occasionally.
Yeah,
What are we doing this week? Yeah.
I'll make sure to mute myself if that happens. But yeah, welcome everybody and thanks for coming along. This week we're going to, we've discussed it a couple of times in previous episodes and we've just talked about it at a really high level, but we're going to have a bit of a look at Amazon Code Guru and how that can interact with your code and what that looks like. And we're also going to just quickly finish off the rest of the Chalice application that we built last episode, and Matt and I went and did a separate stream where we added some extensions onto the top of that. But we're going to use that Chalice application to demonstrate whether it picks up any issues within Code Guru for that. I mean, I don't know whether it will or not, but we're going to try that and also profile that application itself.
Nice.
So, yeah.
Where's everyone from as well? Let's just have a look at like who's on in the chat. I would be interested if anyone has played with Code Guru beforehand as well. I've been kind of geeking out. I haven't touched it all, but geeking out to play with it since its release. So I think it's a perfect way to kind of learn is with everyone here. Give us a call out in the chat where you're from and if you've used it before. But there's a couple of things we did want to do before, right?
Yeah, a couple of little news articles. Maybe I'll do the first one, which is
okay.
Stop and do my screen share here. So I'll share my screen. So there wasn't a huge amount of like releases that I thought mention worthy to the show this week. But one of the ones that I thought was okay to maybe not specifically mention, and might be like a great use case for everybody at the moment. But at least introduce the topic of like the RDS proxy and how that can be beneficial for your applications. So there was a release this past week with Amazon RDS proxy that can be created in a shared VPC. So if you have a shared VPC that enables like different accounts to share that same VPC, so it's not the same as peering, but it enables you to be able to like share that VPC across different accounts, if that potentially might be. And so when you think about like what RDS proxy as a service is supposed to do, this was introduced to help when you're developing and building Lambda functions that are calling a relational database. And so when we think about building applications traditionally in the, any application that we think about when we're interacting with a relational database, we are usually opening that connection and then we're holding that connection open and then we are sharing that connection amongst, either concurrent or, separate invocations of whatever your application is doing. So if that was, let's just say a .NET application, you instantiate that connection to the database and then subsequent requests and interactions with that will go ahead and use that, that same connection. Now, if we think about that in the context of Lambda, where Lambda is, if you think about that, like the invocation of your application happens and then the function effectively is completely destroyed and pushed away. So what is happening there, if you don't think about this a little more contextually, is that every single time your Lambda function is being invoked, it's creating a connection to the database, using that connection to the database and then destroying that at the end of that Lambda invocation. And so what can happen there is that if you have, let's say you have 10 available connections to that database, and you have like multiple concurrent connections happening, you can accidentally exhaust all the available connections to the database, and that, your application will stop working. So I've seen this happen like multiple times in the past, and there's ways to mitigate that, and maybe at some point we can go ahead and do that. But when we think about Lambda functions, there's an execution context, and so you can lift the connection to the database outside the execution context and share that within subsequent invocations of the Lambda function. But even so, if you had more than 10 concurrent connections to the database, or more than 10 concurrent like invocations of the Lambda function, you're going to still exhaust those maximum connections back off to the database. So in comes RDS proxy, which effectively has that connection to the database And then you can, with many of your Lambda functions or applications, connect to the proxy, and the proxy holds a connection open to the database all the way through. So that's the way to mitigate exhausting your connections to the database when you're thinking about and working with Lambda functions. So I thought it was, while like using this in a shared VPC could be beneficial for teams that have, I guess in this instance, you'd have multiple people connected to a database. Like, I mean, probably sounds like it's something that's a little against the way microservices should be operating, but there are still like, legitimate and genuine use cases for this to happen. But I thought it was still worth going into RDS proxy and what it does and how it can, be of value to people that are building these applications on Lambda and might not be aware of some of the limitations they may run into when they're thinking that, oh, it's just serverless and I don't need to worry about it anymore. But what is happening behind the scenes can be, both a constraint to the connections and also like a performance implication because you're opening and closing that connection constantly.
Nice. We did have one question in the chat, not quite related, but I thought it would be worth calling out. I'll put it up for everyone to see. If you have a free-tier architecture application, DB servers, migrating it to the cloud, which one would be migrated first? I think looking at this, my answer is depends. I'm assuming yours is the same, right, Paul?
I think that I would say that I don't think I would ever answer that question as saying like I will take one of those pieces and move it to the cloud. But if I was had to pick something to move to the cloud, and it was the 3-tier architecture, and let's just say the 3-tier architecture had an Angular or React front end, I 100% would be moving the static assets into a S3 bucket. That would be the easiest piece to offload into the cloud. And you can still have your front end like reaching to an API that's something that was on premise, and so that would work perfectly fine. But if you were to consider the next steps for the application or the database, I wouldn't really want to separate those. So I wouldn't want to have my application in the cloud and the database on premise. You have that latency connecting across like a direct link or a private VPN connection or something like that. I would be looking at bringing the application and database into the cloud. I deal with like so many customers that are migrating applications into the cloud and have traditional 3-tier architectures. Like it is still like very, very common for people to go ahead and build applications like this. And a lot of the times there can be, it's like it's an all or nothing thing. And what I think is that we provide a number of different services that can help move that in its current form into the cloud, so you get all the benefits of the cloud, such as managed services, the observability, the monitoring, the performance, the straight up performance. If you get sorry about the wind, if you get some straight up performance by using next generation CPUs or offloading the managing and maintenance of the database into the cloud, think about when you're moving your application to the cloud that it doesn't need to be modernized and moved at the same time. That can be something that is really challenging. Think about some of those other services where there's a specific .NET to contain, what is it called? Like app to container. Our app to container service, might be something to go ahead and look in. And you can still consider your application like a 3-tier architecture. And it's not really like super modern, but it does the job and you've offloaded some of that heavy work. So I think it's like really good to think about your application that doesn't need to be fully refactored into something that's serverless. You don't need to go ahead and put it in a Kubernetes cluster. Your 3-tier architecture, like as I said, I would be okay with moving the front end to the cloud, and then your application and database kind of move those as one piece. And the starting piece to something like that might be simply use EC2, spin up EC2, and move it directly into the cloud, and then realize some of the benefits that you've got because you become more comfortable, more familiar, and then expand that out, and then look to refactor and move away from like managing servers and installing your own database and take advantage of things like RDS as well. So yeah, I think that would be my question that I would say.
Yeah, and I think from a TAM perspective, right, like move what you can is generally what we say. So if you can move everything, that's preferable, right? Because then you can get it done in one big bang, and you're not going to have multiple points where things can potentially break, multiple points in time. But I have honestly seen customers that couldn't move the application at all for 3 months, but they could move the rest of the app, and they had needs to get the app onto cloud, their free tier architecture based app. Other times I've seen customers where, they can move everything bar the database, and they've got 3 to 6 months until they can move the database. And so if you've got a particular limitation, I think you have to work within that limit, and you can't shuffle everything across. But I've seen it work either way. It's just there's always a bit more risk the more times that you have to move things of dependencies breaking, and there's network complexity if you've got half your stuff hanging on premises and half your stuff in AWS. And so, there's going to be a lot more routing, and there's going to be latency between the application and the database. And that's kind of why all at once is good. But I know that we can't do that all the time. And I have seen customers do one or the other first, just absolutely because there was no way that they could move everything at once. But they needed the resilience of cloud for part of their app straight away.
Yep. Well, I have like a this little app that I built many years ago, and I moved that into like AWS not too long ago actually, and it is running on EC2. And my screensaver went on. I'll take that off. So I am running that on EC2, but the database I wanted to move it off SQL Server and move it to Postgres. And so when I was looking at doing that, I actually have a site-to-site VPN connection at home. So from my home network, I can directly connect to like a whole bunch of AWS services within my account, such as RDS, and they're operating within a private VPC. And so I do have like some of that application within the cloud reaching back to on-premise at home, connecting to that SQL Server database while I was in that interim piece where I was kind of moving it across. Now, look, I'm not saying that this is like, a really great practice, but I had it running live in production with half of the data in one database in the cloud, half of it back on premise, and reaching over the public internet. And I had a Raspberry Pi like managing that site-to-site VPN connection using StrongSwan, and it definitely does work. It just adds to the complexity around what is going on there. And if I happen to like turn off my router and for whatever reason that VPN connection doesn't come back up, then my application is hung. So I need to think about that and put some automation around it. So like it definitely happens where people will run the database on premise or the application on premise and the database in the cloud. It definitely happens. And I've worked in organizations where we ran our whole application within AWS cloud, and the database itself was still hosted on premise because like this was several years ago. We needed some specific requirement around that database to happen. So it definitely does happen. There's another question here, Matt. It says, what would you use to migrate Cloud Endure or AWS DMS? So this is by Cloud Guru.
My perspective is DMS is probably the pattern that I see more commonly. But you'll have use cases for Cloud Endure, and sometimes you might actually just do the migration yourself as well, right? Like I've seen numerous times where the customers moved all their infrastructure. They have a mirror copy sitting in cloud. They have a switchover event. The main piece that's the complexity on that's like what's going to happen with the database, right? Is it okay for the database to temporarily be out of sync? Or do they have a scheduled event where they do the switch and the application's not available, and then that way they can just like hard cut over between on-premises database and cloud. But yeah, let's have a quick look at DMS, Paul. I just see you've brought it up on your screen in Cloud Endure.
Yeah, so I like DMS is a service that actually I'll go back and I'll switch the page. So DMS is a service for replicating data between databases. So and that not necessarily be like on-premise to the cloud, but typically it is something like that. So DMS is a service that helps you migrate your databases to the cloud and being able to operate in an environment that might end up being, let's just say for an early, as you're going through your journey of migrating to the cloud, you are stuck with some of the application that is running on-premise, but you've been able to move part of your application into the cloud. And let's just say that part of the application into the cloud is like the read-only piece. So you move the application to the cloud. You then have an RDS instance or a copy of the database that is a read replica, but it's not doing just a stock standard read replica where we would use RDS to determine a read replica. That read replica is being fed and the data pushed into by AWS DMS, so the database migration service. So that is hooked up and is continuing to look on that database, and in this instance would be on-premise, looking for changes that are occurring in that database and continually moving that up into the cloud. So then you have a secondary copy of that database in the cloud that might be like, just slightly behind, but has the ability to pull that data out. So DMS is used for when you're at a challenging point in time where you're looking to move your data from on-premise into the cloud. And part of that, and often what happens with DMS is customers have chosen to move away from I guess what do we determine as like the old guard databases, so SQL Server or Oracle, and they're moving to the more open source environment databases such as either Postgres or MySQL or Aurora, which supports both of those. So as part of like DMS, you also have the ability to do some changing data types and moving the data across that is not necessarily just available to say, hey, I want to take this export from Oracle and I want to put it into Postgres. It's not just magic. You can't just do that. There's a process that has to go through when you're working with that. Whereas Cloud Endure, and I didn't find, when I quickly just Googled that, I didn't find a page that sort of goes over Cloud Endure. This page happened to come to the Cloud Endure disaster recovery page. But Cloud Endure is a platform for, replicating whole environments into a secondary location. So you can use that to migrate and move things into the cloud. But Cloud Endure is like, if you were installed or manage that database or application itself, like the whole machine can go ahead and be able to move in the cloud. So I do see, customers, using Cloud Endure to say, look, I want to do a real pretty standard lift and shift operation and just suck up all my virtual machines and move them and deploy them back into the cloud. We've got another question here from GekDev. When should I use AWS in Rora instead of RDS?
Yeah, that's a good one. I mostly stick to Dynamo these days, actually. So I'm more of a Dynamo fanboy, which is different to the older days. I think Aurora is going to give you really, really good resilience. There's a lot of special source that goes into the service itself. It's able to expand up and down really, really quickly. RDS is a bit more traditional, like you've got read replicas and you've got your master node, and you can have it running in multi-AZ as well, so it's a good option. But what's your view on this one, Paul?
I think that one of the big reasons that customers come to Aurora is that they want the performance of like Oracle or Microsoft SQL Server without the cost. And so that is like one of the big reasons that people come across to Aurora. So I'm going to guess here. I think it's like, is it 5 times for MySQL and 3 times for Postgres?
We'd have to look it up. Actually,
look that up.
Yeah, let's have a look.
So where does it say performance? We'll go to the performance. So 5 times the performance of MySQL and 3 times the performance of Postgres. So there you go. I must have done some study enough to see that. So these are one of the reasons that customers come across to Aurora, because you can go ahead and move your application to these open source implementations or open source compatible implementations, so MySQL or PostgreSQL, but still have like the performance that they expect to have when they were using SQL Server or Oracle. One of the other reasons is, and if we look at, I'll quickly look at it, is the Aurora serverless options. So using Dynamo, and Dynamo is so like handy because it is like hands off and it is serverless. But when we think about like a serverless relational database, like Aurora is basically the only option that you have for something like that. And I've used it in the past, and I've used Aurora Serverless V1, and I found that my application was, when I was using V1, unless I had a heartbeat or something to keep the service up, the cold start was a little too slow to be able to go ahead and start that instance up without implicating the consumer in some way, shape, or form. But what Aurora Serverless, both V1 and V2, allow it to do is basically if there is nothing connecting to that database, it will turn itself down and completely turn itself off, and then start up when it needs to, like later in the future. So I guess in effect, it's a database like running in Lambda. Like, I mean, it's not really, but that's how it feels and operates like. With serverless V2, the cold start time has been dramatically improved, and almost to the point where you just don't really notice that happening. And secondly, when you have Aurora serverless V2, you can scale your application like vertically. So basically, put more CPUs on your relational database, which is effectively the only real way to scale a relational database, other than with read replicas. But you can do that on the fly, and it happens almost instantaneously as well. So if you have an application that is really heavily tied to, a MySQL or Postgres database or a relational database that you've migrated and moved across to Aurora, then Aurora serverless is something that could be really beneficial when you have like really rapid traffic growth or traffic spikes. So you pay for the cost of that scaling up and down, and you can see here, you pay for a per second basis of the database capacity while it's active. So, it just provides you with that ability to scale your relational database up and down really, really rapidly. But there's some other really neat features of Aurora as well, such as the global replication. So you can replicate Aurora around the world the same way you can do with global tables in Dynamo. Aurora also has a number of different features that are quite interesting, such as when we think about like using a relational database and triggers, or if we were in like DynamoDB, we got streams at the back of a DynamoDB stream. You can use Aurora to have triggers that trigger things happening in your AWS account, such as triggering a Lambda function, and that could be like really useful where you have that native integration to be able to go ahead and do things, and that might be I don't know, something like a status change on a person's role within an application that can go ahead and trigger some sort of Lambda function that can go ahead and produce a new certificate of attendance or something like that. I don't know what it might be, but it provides you with that ability to do like event streaming off the back of a change within a database. So that's another reason that Amazon Aurora is a really popular service.
I can see we've got a bunch of other questions as well. Philip J. Fry mentioned Dynamo Hype. But we did have like a multi-cloud question come in, connecting multi-cloud workloads, AWS, and other cloud services provider. I actually think we've done a couple of videos, and I can put the link to them in the chat, but we've been exploring like App Runner and Copilot in the background. Oh, sorry, no, I'm getting myself confused. We're exploring ECS Anywhere, basically, like where we could run ECS on, other clouds, or we could run it on our Raspberry Pis and this and that. So that could be a really good option there. But I know that there's a ton of stuff, a ton of tooling coming into space and recommendations coming into space, because you've got to really come to a balance of like what you want from each of the clouds. No cloud is exactly the same, and so some people take the approach of like, we're going to use the best of each cloud, and we're going to have some resilience between the clouds, and the fact that we're not reliant on one provider if they disappear. So there's practices around that we've kind of released over the last couple of months, I know. But then there's also like, what happens if we want more of a containerized approach, and do we run containers across the clouds? And there's a lot of complexity that comes into that conversation, because the network basically expands between the two sites. And so the recommendation would be do one really, really well, and then work out what to do on the next cloud. I can see you putting in the links, Paul. We both have spent quite a bit of time on multi-cloud, actually, so that could be a wider conversation sometime, where we could run through the options. I know, Paul, you're a big fan of Cockroach DB, running that across multiple regions or multiple clouds, or this and that. But you've also got to tackle the containerized approach. You've got to tackle like how you handle like access rights to the cloud and rights to the services. You've got to look at like centralization of all your core services, like logging and this and that. That's why I think maybe sometime we can share a bit of our experience over an hour on what we've learned across all the things, and it's all going to be dependent on what you can do as an organization, and how you want to approach it.
Yeah, I think that it's like that's one of those big depends pieces that probably will take, you know, one or many hours to talk your way through. It is a lot of the decisions around hooking up to multiple clouds and on-premise, or like, you know, a real hybrid network is around like what is it you're trying to achieve at the end of the day, and then you can provide some recommendations. If you want something that like is exactly the same on every single cloud, that's going to be really difficult. If you want to leverage a specific service for one cloud over the other, then maybe that makes a lot more sense, and you can be then really hone in on what it is you're trying to achieve, and how you might go ahead and set up and architect some of those features. But as we talked about, there's ECS Anywhere, there's EKS Anywhere, and so that there are some of these platforms that are saying like if you do want to extend the workload between the clouds and have a single control plane or a single way to go ahead and manage them, some of those tools can help in those environments. But
on
even
like as well, like with Outposts, right? So you might not be able to get an Outpost installed in another cloud, but if you've got like on-premises and you want to expand what you've got in the cloud back to on-premise, Outposts is a good option there as well.
Yeah, I'll just for people that have never seen an Outpost before, an AWS Outpost is like effectively an AWS rack that you can put in your data center, and that has like certain features of the AWS cloud on it available. So there's S3, there's EC2, there's RDS, there's a bunch of other different services that are available, and you can run that within your private network. So it's an extension of the AWS network that running on premise. So that would be useful if there was a compliance reason that you needed that like on a specific premise, or it might be just straight up a location thing, and that might be, I don't know, let's just say we're from Australia, so there's one of the mining companies maybe is using an Outpost or something that needs to be really close to a data center to get information about the rocks that they're collecting or something. And latency over the internet is just too low for the amount of data they want to send, or they don't have bandwidth throughput to be able to handle that. So they want to store that data locally, but they want to maintain the consistency of the overall service lens of AWS.
Yeah, and Cloud Guru's asked one more question. I know we've had a really good conversation actually for half an hour, but what we'll do is we'll move on after this. But how do we split the workload between the CSPs, right? So yeah, and the speed of light problem, like this actually comes down to my response to the speed of light problem. And that's, rather than looking at running the same thing across two clouds at once, which suddenly you have latency that you've got to worry about and added complexity to your networks, including like, how the backbone providers are working between both clouds. I would always go with the recommendation to start, like master one cloud really well, and then take the benefits of some of the other clouds. And so, if there's something that a particular cloud does really well for your use case that isn't on offer on the cloud that you've mastered, feel free to use that other cloud and host that particular part of the workload. If I wasn't in AWS, that would be my approach as a customer. Still, so I'm trying not to be biased here, but I do think that there are so many different nuances between like how we do Lambda and how other clouds do function as a service. The core capabilities that we have around VPCs and networking or IAM, like everything's quite different when you actually start to do comparisons. And that's why I think the best of breed approach is probably the safest and the best. But I'd actually say hit Paul and myself up on LinkedIn. We can chat more about this. We can share some of our learnings, and then that way you can kind of work out based on what you're trying to solve, what might be suitable, and we can kind of give you some of the guidelines and recommendations on what you need to worry about or what you need to sort out to approach it. But I do really like GetDev's response, speed of light problem, because that's the key thing, right? Like, especially if you want to have like a database shared between two clouds. It's the same as having a database between on-prem and cloud. You're always going to have latency. You're always going to be subject to the physical cables that are transferring data across the internet, right? And that means that you've got to handle data consistency problems as well, which get very, very complicated very, very fast. So I know we were just talking about the RDS proxy stuff, but I think this might be worth having another session sometime. with everyone, because there's a lot of interest. But what were the other features quickly? And I do want to get to CodeGuru today as well.
It was Amplify's hosting supports Next.js version 11.
Yeah, so this one, I know that there's a lot of people that have been excited about. Now, Amplify's got really good React, Angular, Vue.js style support. But one of the things that was really hard to do with Amplify was support basically like SSR type systems. So so when you were doing like server-side rendering, essentially, it was really hard to get your Amplify projects working and the routes configured correctly and this and that, because a lot of the Amplify is serverless and spun up instantaneously, and it relies on S3 and a bunch of services in the background to host. So the Amplify team over the last year has done a lot of hard work to do a lot of really clever things alongside like S3 and Lambda, to essentially allow it to work with server-side rendering type products and getting the routes right, getting the hosting right, getting handling authentication in those scenarios right. There's like every part of like what Amplify offers as a library basically had to change for this. But we've got Next.js working. We've got Nuxt as well, if anyone's used Nuxt. So Nuxt is now working, and I think Gatsby and a few others, if I remember correctly. We've gotten working with server-side rendering now, so it's a really good win for customers. I think this is a really nice feature to have, considering the popularity of each of these frameworks.
Yeah, it's really interesting because, like Matt and I have actually dealt with, like we've worked together with a couple of customers specifically around Next.js and the challenges and the problems they go through. Like customers want to stick with one language. They like React, but they want to be able to do have good SEO. And working with server-side rendering and React in the past, it's always been difficult. You've basically needed a server or something to go ahead and serve that up. And so, when you think about, and I know that Matt and I have programmed a lot in like Flask or Chalice, and we've thought about like how you would go ahead and like build your application and make that serverless, but have it served from the server rather than having an SPA. So, that rich experience. And that can work really fine to say for my brochure-based website or something, that I have that all server-side rendered and let that be like WordPress or whatever, a Flask application. But to actually build applications that feel really rich and feel like a proper application within the browser, you basically need something like, React or Angular or Vue, one of those really nice front-end frameworks. And getting the best of both worlds is challenging and really difficult. And Next is probably the biggest player. Like I would say, like the most one that I see and get called out with. So it's really good to see this being supported in Amplify, and we'll have to have a play with that one day as well.
And Next backs into React, right? So there's a lot more complexity that you've got to think about with these things like Flask and Django and like PHP Symfony and all those really old school frameworks. With server-side rendering from the start. You knew what was happening, like you were controlling the routes on the server, you were doing all the rendering. React really brought a lot of the rendering and the logic and the handling to be done by the browser within the consumer's device. And so there's a lot of blurred lines with Next where you've got to think about what's happening on the device when you use Next, as well as what you need the server to handle. How does the server know that it's changed? How do you know the device needs to have an update or knows that the context of like what's happened on the server's changed as well? So it's like really interesting stuff. And I know that it literally took about a year for our team to come out with like pretty good support for Next.js on the Amplify side.
Yep. So with that being said, I think we'll go back and go ahead and like look at what CodeGuru is. But as part of before CodeGuru, what I'm going to do is quickly show that as of last week we had our rock paper scissors app, and so what I'll do is I'll copy and paste this so that our audience can go ahead and play the game themselves if they want to. But Matt and I went ahead and finished off that rock paper scissors app, and we allowed it to be able to push down the CSS, have the styling, puts the emojis in. I'm running Linux, and for whatever reason, the rock font is not available on Linux. But we also got the image serving out, and this is all serving out through Chalice and Lambda. So I'll just quickly show that works. So we can see that, like, here's the application. You know, we pick scissors, again, and then we'll say I chose scissors, computer chose paper, I won, go ahead and try again. So that's the idea of the application. We also added in an error page, and just to show how this would work, if we go inspect and we look at, where is it, network, we reload that, this will come back with a
404 at the top.
Yeah, so it's a 404. So we are specifically sending back a 404 error code on this page, and you'll see why that's important in just a second. So why did we, like, why am I bringing this back up again this week? And I'm not going to, like, really go into the code other than to say that when we were thinking about our application, we were wondering about the performance implications of this application. And we've talked about it and we've used it before, but there's Locust that is a load testing tool. And so we wrote last night, Matt and I sort of poked around with it, and Matt finished it off today, but we wrote a small load test script for this, our rock, paper, scissors application. And we used Locust to go ahead and do that. And if we have a look at the way Locust sets this up, is we basically have a number of specific tasks that we're going to execute and do. There'll be some specific wait time between when those tasks are executed. And then there's a user interface that enables you to start this and let this go. And I'll show that in just a second. But basically we say we do some gets, so a bunch of gets. So the get is just on the base URL. There's some error calls. So the error is like looking for that /error page. It's just so that we can capture a 404 response and see what happens there. And then there's the post. So the post is basically saying, randomly choose between rock, paper, or scissors, and then post back to that result page the choice that the human is going to go ahead and make, and then show us that response for that. So basically it is saying, like, we'll do some requests to the error page, we'll do some requests to the home page, and then we'll do some requests, which is effectively somebody going ahead and playing the game. And just to remind everybody, this was that Chalice application that we built, and Matt can probably paste in the repository that we've made for this that shares that out. It's a very simple application that basically worked out, if we look at where the logic was, what you chose and what should win, and just returns you lost or you won for that. However, we extended that a little bit more last week because we wanted to include the CSS and the images. So we twisted and bent Chalice a little bit to be able to, like, read specific files off the file system based on a specific route. So if you get /CSS and a CSS file, so if we were to look at this page here, and we look at this URL, we can see that, like, it's /CSS/main. What is going to happen in the application is that we'll go ahead and just open that file off disk based on what it was, and then just serve up the content of that file. And I'll explain what this was doing in just a second. The same for an image. So if you look for /images and an image file name, so if we were to go back to here, and I right click on copy image location, and I'll paste that, we can see that, like, there was a specific image that we're looking to, and it will go ahead and serve up that content. And so that is basically doing the exact same thing. So whether it's performant or not is beside the point. We were sort of manipulating Chalice to do what we wanted to do to host our whole 3-tier application effectively within Lambda itself. But we can see here what is happening is that's reading that binary file and then just serving up binary content. And so if we think about what is happening here and we look at the top, for the CSS file, we need to string encode that string back to binary, because the way Chalice works is it expects all the content to come back as not binary, or all of it to come as binary. So we had to change our application a little bit to say that we're going to serve everything out as a binary, so binary encoded string, which means that every one of our functions here is now returning bytes. Like, so it's returning bytes back to API gateway, and API gateway is then doing that transformation. This specific command here, app.api.binary types, if you don't set that, those binary types will be set to, if it was a PDF or something, you would have to pass an accept header in to get that back. Whereas at the moment now we're saying we're just always going to send back a specific type and not enforce the browser to send an accept header to be able to get that content back. So that's just a little bit of a summary of what we did with the application. And
I'd probably preface it, right? I'm just thinking, like, should you do it? Probably not, right? Like, you'd want to host those assets, usually like the CSS, the images, like on S3. But can you do it? That was kind of like Paul and I were having fun, right?
We just wanted to do it because whether you should do it or not, like, that's beside the point. We probably would recommend you host your static assets within S3 and then CloudFront in front of that, and use your your backend to be able to serve out, like, either, like in this example, that static content that is rendering out that Chalice app, or just JSON and interpret it that way. Like, that's probably a better use for Lambda. But can you do it? Yeah, sure. That's how you could go ahead and do that.
Yeah.
So with that being said, I'll fire up that locust file, and I think it's just locust. That's right. I had to specify a specific port for that to run on. And I probably got that running twice. So locust is that web application that is going to go ahead and just call our application over and over again. So if I go to
Are you getting extra C in localhost?
8,001 actually, I think was the port I said.
No, I think you did 8,000. You changed it from 8081.
Yeah, you're right. So here's locust, which is, we're going to say how many users do we want to hit that API. We'll do 100. I'll do a spawn rate of 5, and I'm going to take this as the base URL and pass that in, and we'll start seeing our application being called, like, over and over again through locust to call that API. And if we were to look at what is happening here, you can see all the responses that are coming back. So we can see the 400s and 200s. So we know our application now is, we're generating some load on the application. Now comes into why we might think about using, like, Code Guru. And I suspect that we're going to have to either run late today, or we're going to have to revisit the service itself again in another time. But there's a couple of different features around Code Guru. One is it can review your code, but there is also a profiler. So I thought it would be useful to start off by showing how the profiler can interact with the Lambda function that is running, and we can get some insights into how that application is running itself. So if we go to the Code Guru service, we can see that we're going to go ahead and create a profiling group. Now, I did create one earlier, but I'll go ahead and I'll delete that, and I'll show you how we can set that up. So we'll create a profiling group, and I'll call it RPS. This is
no one's after us, Paul, just FYI, so we can go a little bit over if we need to.
Okay, sure. And with Code Guru, when we go through this, we set this up, you can choose other or Lambda. In this instance, we're going to choose Lambda. Other, you can go ahead and definitely do that. So, you can even put it on-premise or EC2 or anywhere you really want. And that requires you to build and package in the dependency of the Code Guru profiler into your application that you're deploying. But with Lambda, it's actually much, much easier. The Code Guru profiler supports, at the moment, Python and Java, so Java 11 and Python 8. So we basically configure this up, give it a name, and tell it that it's Lambda, and we click Create. And we're going to do this for Python 3.6. And the first steps that we're going to do is we need to set permissions. So what we want to do is choose the role that is used to execute your Lambda function. So we want to make sure that the role that is running that Lambda function has access to push data into Code Profiler. So if this is my Lambda function, this is a Lambda function that we deployed before, so I know this is running at the moment. And if I was to go to monitor here and look at some of those metrics, we should see an uptick in requests because that is running in the background. So we'll see that come up in just a sec. So we can see here that, like, all of a sudden we've got, like, basically 0 invocations that were happening, but now we've got thousands of them happening in the last minute. We can see the average time, the error counts, and what is happening there. Whether something is not occurring the way it should be. If we were to look at concurrent executions, because that is running, it doesn't run in a thread, but it runs in a separate. It doesn't quite run in a separate process using Locus, but we can see that there's been 16 concurrent executions of Lambda. It's like the highest that it's seen so far, and that was happening there. So that will depend on how many people are calling that Lambda function at the exact same time. But even so, we're still seeing that we have look here there was some looks like there was we got 100% success rate, so we've had no errors come through. So that's really awesome. We know that Lambda is scaling the way we expect it to scale. If we think about the duration, and if I change this to the last 5 minutes.
5 minutes, right? Yeah.
Yeah. So we tend to see with duration, when you go ahead and scale up your Lambda functions or your load behind a Lambda function, duration might start off a little high, and that's the cold start, so the Lambda itself starting up. But as I mentioned earlier when we were talking about RDS proxy, that Lambda function can be reused the next time you run through. So it's already warm and it's already ready, and that's where we start to see that dip. So if I went and changed that locus file now, and I had it running nice and warm with 100 concurrent users, and I changed that 100 concurrent users to be, let's just say 1,000, we would expect the duration to bump up momentarily and then dip down and stabilize at a certain point across the duration here. Now I'll leave this running, so that'll be collecting data all the way through. But what we will go ahead and do is I want to look at in configuration the permissions, and I'm looking at the execution role. So this is the IAM role that this function is running under. It is doing nothing, so it probably has very minimal permissions, which is probably a basic Lambda execution permissions and the ability to log out to CloudWatch logs. But it's RPS Chalice Dev API handler. So I'll go back to here and I'll look for that permission, and I'll see that will be RPS Chalice Dev API handler. So I'll go ahead and I'll save that. So now what I want to do, and of course you could codify all of this, but we're going to do it through the console so we can see what is happening here. We want to turn on profiling for this application. Now, as I said earlier, you could bake in the dependencies to your code and go ahead and deploy that. One of the features around this that was prior, just a few weeks ago, was you would use a layer. So you'll be able to have a layer, and the layer would sit on top of that, and that was all hooked into Code Guru. But it's even simpler now. If we go to, where is it again? Monitoring and operation tools. And we go into here and we see Amazon Code Guru Profiler. So basically we should just be able to enable this. Now, I've never used this before in this way. I've always done it as a layer. So hopefully this is the way you're supposed to do it.
This only just came out last week, right? So
yeah, and I actually thought it would be more fun for us to sort of go through it and see whether it works the way we expect it to, based on following the information in the document and my understanding of how the services work. But that's worked, right? So we can see here that that's worked. Well, it says it's worked, that it's enabled. So I'm guessing all the permissions are set up right. So if we look back here, and if I look at, it says that. Okay, so profiling group's ready. The profiling data, it says it's been received. The agent's been contacted. This bit usually takes, so here we go. So multiple times for a consecutive 5-minute periods. So in a few minutes, we should start seeing the profiling group for this. Okay, so it didn't work exactly the way I expected. It's created it itself. So, okay, it just must do it for you. So it's not exactly the way. This would be if you're configuring your own profiling group. I can see that has come up. So I guess it went ahead and set up all those things for us. But anyway, this looks like it's working. So there you go. You see how that works. But basically, we probably didn't need to do that profiling group step. But all we needed to do was go ahead and click that, set that option up, and that has permissions enough, authority to go ahead and enable the permissions for that Lambda role to push code into this profiling group that's gone ahead and created up. So this does take a few minutes to go ahead and do that. So while that's happening, we'll go ahead and I'll show what the Code Guru service itself does for your actual code repository. And so if we think about like what Code Guru as a service is doing is it is machine learning pull request or a machine learning code review. So using a whole bunch of open source repositories, as well as like Amazon's internal specific code bases and good practices, they've built up a really nice machine learning model around what good code should look like. And there are specific things it looks for around security, identifying, specific tokens that exist in code, such as like an AWS access key or secret that's accidentally committed to source code. And if you think about anybody that's been in a development role, code review is something that has basically been around forever. But if you roll back into the past, before the time of Git, pull requests weren't really a thing. It was something that you'd sort of sit down with the team, you'd look at it, or someone's eyes would skim it before it went to production. As time eventuated, that became as part of like your your software development lifecycle, that before any code goes into there's even the staging environments, there's a pull request that happens, and two people within the team might need to go ahead and look at that code. And so like that's a process. It takes time to do that. Having worked through many organizations where you've had people within the team that like to scrutinize code and look over it, and there can be really smart people that like complexity over simpler code, and so they'll put their 2 cents in. We'll have people that are very particular about maybe something that was like spelling or linting, and a linter should take care of that. Code Guru doesn't do linting. But some of these things, you always wonder, are they providing the real value that we expect when we're performing a code review? So Code Guru does that with it's automated and a machine does it for you, which means as an individual, you're far less likely to take offense at a machine telling you you're doing something wrong. So you feel really comfortable to go ahead and do that, which means I'm more likely to not procrastinate putting my code through a code review and feel that there's some security coming out of the back of that. Secondly, if the automated solution picks up some issues with my code and I fix them, then I have more certainty about the quality of my code when a human is going to go ahead and look at that. So that's a base overview of the Code Guru service. But what I'll do is I'll show you how we go ahead and we can figure that up. So I'm going to connect this with my GitHub account. And
is it going to judge us for not having unit tests? This is a quick app that we mocked up, right? We're missing a couple of things. Let's see.
Yeah. So because this is in devs in the shed, what I'll do is I'll do it on this RPS Chalice, but I'll fork that quickly into my personal account. So that will exist there now. It's probably because it's loaded that account. I'll just have to refresh this page.
Yeah. There it is. Was
it there? RPS Chalice?
Yep.
Okay, there it is. So RPS Chalice. So all I'm going to do is I've logged in with my GitHub account. It's made an association with that. If you want specific encryption keys, you can do that in tags, just as usual AWS tags for your costing and billing. Once that happens, we now have an association between that repository, and you can use Bitbucket, GitHub, GitHub Enterprise, and Code Commit. We should see that associates pretty quickly. Were there any questions in the chat, Matt? I haven't looked for a little while.
No, some people have been talking about the rock, paper, scissors game, having fun in the background, so that's awesome to hear.
Yep.
Feel free to ask questions in the chat. Yeah.
So that's been associated now. And so when we go ahead and we look at what we're going to do with our code review, the first thing I want to do is I want to perform a full code analysis, a full repository analysis. So I'm going to pick that. I guess we did that as main. I'll just double check that was, yep,
I think it was main.
Yep. And so that's some randomness around the code review name. And I'm going to go ahead and just kick off a full repository analysis on that. And that will take a few minutes to go ahead and perform the analysis, and it will provide us some insight into what are some best practices that we may or may not be, that we may be missing within our code base and application there. Now, as I mentioned earlier, Code Guru runs for Python and Java. So I'll also do another application, a Java one. So there are a couple of specific apps here, and we can follow these instructions. So I'll paste this into the chat, so if anybody wants to go ahead and follow along. Code Guru has 90 days free, so you're free to go ahead and try that. But be careful with the repository reviewing limits, because you don't want to, do a full repository review like hundreds and hundreds of times there. So I'm going to fork this Java application to my GitHub account, and then we'll follow through the steps to associate that as well. So I'll associate a second repository, and that was, what's it called?
Amazon at the start. Sample app, yep, that's it. It's just there.
Yep, so is that one? Yep. And I'll associate that as well. And what I'll show with this is, rather than doing a full repository analysis, I'm going to show how this would work if you were in your typical software, workflow, and somebody has gone ahead and made a change to the code base, created a pull request, how this interacts and hooks directly in with, GitHub or code commit or whatever it is. In this instance, it'll be GitHub. So when I've made a pull request on GitHub, what is that going to look like within the Code Guru, pipeline, and how you can see the difference. The Code Guru won't do a whole repository analysis, but it'll look at the difference between like the before and the after the commit, and look for differences that might be, that it's going to provide some recommendations against. So I definitely know now I have that association there. If we go to code reviews, there are no incremental code reviews. This one is still pending, so that's fine. But we'll go ahead here and we'll follow the instructions here. So I've forked this repo, and that is going to want me to clone that. So I'll clone this repo. So we have a look now. We can see, this is some sort of Java app. I'll open it up in code so it's, we can just have a quick look at it. I'll open a terminal here as well. So there's just, I don't know, it's just some resources, some sort of event handler for some sort of Java application. It's here. And I think what's the next step is, here we go. So the next step is to check out a branch. So this is normally what we would do. So we'll check out a branch in our app. So we've created a new branch called dev. We're going to copy this file. I'll just click this here. And I'll show what this is that we're going to do. So there should be a new file now in what file did it copy? Event handler.
Yeah, does it replace?
Yeah, that file didn't exist. So if we look at the top here, if we look in shipment events, in the handlers, there's the event handler there, but inside demo, that file isn't there. So that's what it was before. So we've copied that file into that demo folder. So there it is there. So if I was to do git status, I can see that there's a new file that's there. Just to make sure I don't make any mistakes, we'll copy this all out. But basically we're doing git add all, git commit -m new file, git push. So we're going to push that up to the origin. So I'll push that up, and we'll see. Okay, so if I go now to here and I look at my, we can see there's two branches here now. So there's the dev branch, the one that I've put in. So that's exactly as we expect. So now we've got two branches. Code Guru should have done nothing because there's just a new branch there. But what we want to see is Code Guru go ahead and trigger off a code review when I go ahead and do a pull request. So let's go ahead and set up a pull request for that. So I'll create a new pull request.
We've got a good question that came in actually as well, Paul, while you're doing that.
Yep. I'll just do this and then I'll answer the question because
cool.
It takes a minute or so. So here's my pull request. Make sure when you are working through this that you make sure that pull request isn't accidentally back into the upstream repository. So that's the difference. So that file has been copied to another location. We should see a review on that specific file there. So I'll click create pull request, create pull request. I will just quickly look at that question that's come up.
Yeah, so X-Ray's performance and architecture, Concurrent Guru is really about reviewing the code. So I think your logic tree is spot on, right? X-Ray is really about the real-time performance of your app, noticing things that go wrong. If errors start scaling up, X-Ray is really good at giving you real-time observability. X-Ray is kind of similar to Devops Guru as well. X-Ray is really detailed in understanding how your app works, and it'll alert you and show the tree of what's working in your app and the status codes, and it shows it nice and visually. Devops Guru kind of just looks for signals that have gone wrong versus standard. So Devops Guru is something that you could look at as well as maybe an alternative in some aspects to X-Ray. But Code Guru is really about do I have security issues in my code base itself? What could I do better in terms of the code? Are there optimizations that I can have? It's got the profiling aspect as well. So it can kind of look at your code and make some recommendations that might give you gain performance or tell you where the performance bottlenecks are happening. So they're quite separate things. So I think you're thinking of them in a really good way, but I'll let Paul add to that question as well.
Yeah, X-Ray is a service for when you were thinking about, let's just take, for example, you're calling a Lambda function. A Lambda function is putting a message on a queue, and that queue gets picked up by another Lambda function, which then goes ahead and writes something into DynamoDB. Following that trace through distributed systems like that can be really difficult to piece together what has happened along the path. So X-Ray comes in real handy for doing that. So it is it's such a good service name because it's X-Ray, because you're looking behind the scenes at where your information and data is traveling through your internal mechanisms. So that's especially valuable in a distributed system.
And you can go into CloudWatch to see the execs as well when you find the particular component that might be causing some troubles, right?
Yep. So I don't think we turned it on for this at all.
No, we don't have X-Ray enabled for this.
Yeah, so we didn't turn it on, but we could have turned that on, and then you'll be able to see where that's coming and going. Although in this instance it's doing nothing, so it would be very boring. There'd just be one circle in the middle. But Devops Guru is another service that we can look at that another time as well, and it'd probably be useful to turn it on. That basically looks for things that don't look right, I guess, things that look different to the way they looked before. So Devops Guru is another machine learning based tool, especially to help support developers where something doesn't look right in your account, and it alerts you that something is happening, and was that related to a specific change. So it looks through CloudTrail and determines whether there was an infrastructure change or a deployment that happened, or whether your CI/CD pipeline go ahead and pushed out a change, and that change has caused an effect that something is going wrong at that point in time. So that's another useful tool.
Or your particular machines run out of memory or whatever, like your EC2 instance. It will just look at what the normal running state is, and then do a comparison to the real-time state, and then it'll go, I think something's wrong, and then it'll try and push information for you to investigate.
Yep. So back to Code Guru. So when I went ahead and made that pull request, I did nothing here, but we saw an incremental code review kicked off. So there's a hook between GitHub or if it was code commit as well. The hook has kicked off a code review, and the code review will kick off and look at that changed file or whatever those changes specifically were, and analyze that and look for something that might be wrong. So there is a bunch of different things that it does. So it does look at thing at a high level, cyclomatic complexity. It looks for if you've accidentally committed a key in there. It looks for security best practices. It looks for AWS SDK best practices, as well as help you identify some of the OWASP top 10 security issues as well. But for the full security repository analysis, which is our RPS application, it's found something. So let's have a look. So it's saying app.py on line 72. It says this line of code contains a resource that might not be closed properly. This can cause a resource leak or slowness to your system. So I wonder what this is. Probably something about reading a file and not closing it. There we go. It is.
Yeah.
So this is literally saying that I'm not. Actually, it says that we close it. Maybe that's just because it's not try catch. Yeah. That'll be because it's not in try catch. I'm sure of it. Because if an exception was thrown and we didn't close it, that could leave a file pointer open. I'm sure that's what it will be. What does it go there and says? Oh, here we go. To prevent this resource leak, close F in a try finally block or declare it it using a with statement. So exactly like, I guess what I thought, like put it in a try catch to make sure you go ahead and do that, best practice. So if we were, we'll do this later and we'll maybe Matt and I will do it in a subsequent show, just not on the AWS channel, but we'll go ahead and we'll do that and we'll see this recommendation hopefully like disappear. But this is, a good example of where we're saying if you're building an application that is run in an environment that is going to go ahead and let's just say this was running on a container and that container was having some specific crash and the exception was being thrown and you weren't closing that, then it could potentially cause a resource leak. And that's where you can see, CPU or memory, explode on a server. So even though you might have wrapped try-catch around that, if you didn't close that off, that file pointer off, well, there's a possibility that you've left that file pointer open. So it's, providing good practices to go ahead and do that. It also provides, so that was a deep link back in, which was handy. And if I click back on that, we'll see that if you go to the pull request. Oh, no, because I didn't do it on the pull request. Yeah, it's not a comment. It's just telling me that specific line. But it also provides more info. So a link that will tell you, use the with statement. And I guess that says, destroy it once it becomes out of scope or something like that.
I've remade the change, but you forked the repos, so we can't test it.
Yep.
Yeah.
While the Java one is still kicking along, we'll just quickly look at this. Okay, so this looks like it's properly profiling now. Because it's come to the piece, and it looks like here it says 0.9 Lambda. I mean, that's kind of interesting that it says 0.9 Lambda agents, but whatever. Let's go ahead and have a look at the CPU, what is going on behind the scenes, and what this shows. Now, if we were running Java, you would have a little bit more information about the heap as well. So with Python, it doesn't look into the heap. But it does look into where the application itself is spending its time. And so based on that, you can say, where would I like to redirect my efforts to improve the performance of this application? And so this can be really beneficial. One, if you're doing cost optimization, I think cost optimization is especially important when we're thinking about serverless environments and operating within a serverless space, because we are paying per millisecond of execution. And if we have something running for 5 milliseconds versus 1, well, it's 5 times more expensive. Now, if 5 milliseconds was happening on straight up EC2, well, we might never see the cost implementation of that. So it's it becomes even more important when we're running in a serverless environment, because the cost savings can be quite dramatic. So you really start to think about how to cost optimize your workloads and look into the structure of your application and where you can save some compute execution time. Secondly, that can be, if you have some hard evidence, that can be beneficial to go back to your business and say, I'm looking at this specific piece of code and I know that code is taking a piece of time. And let's just say this one is file. This specific piece, running it the way we're running it at the moment, is costing us $32 a year. Now, $32 a year might be completely negligible in this circumstance, but if we had an application that was costing $32,000 a year, and we could say, well, if I spend 5 hours optimizing this line of code, I can reduce the cost of that by 10%, and that's $3,200 a year. then that ends up being like $600 per hour of benefit that you're providing back to the organization. So it can be really beneficial. I also think that as somebody that's led many development teams and had many different opinions with development teams, the inverse of that can be also true. I will find that people will say, or developers will say, I'd really like to refactor this code. And I say, well, what's the benefit of doing that? They say, oh, I want it to run a bit more, performant. And I say, well, I'm looking at this code. It's only cost me $32 for a year. So unless you can do that refactor within 5 minutes, it's not a good, cost benefit. So maybe we'll push that one back to another month as well. So Matt, have you ever had a look at this, or is there any questions or anything that you wanted to go into with this?
No, I have looked at it before. I did see that the chat's kind of got a few things happening in it as well. Like
Okay.
Pellet Line asked, can I trigger Code Guru manually, like from inside code builds? So
yeah,
you can create a manual code review if you want, and you'd probably want to do that through like AWS CLI, but I'd have to see if the command's there. It's not built into like code pipelines, code build steps. We have got it working with GitHub Actions though, so you can create a code review in a CI/CD type setup if you're using GitHub Actions to fire off the requests.
Yep.
Now, this is evolving really fast, right? Like we've got Python, Java, they're working on other languages. There's new features being added in. So this service is going to evolve over the coming months quite rapidly, I feel. The next one was from Valerian Steele. IDEs automatically should give these recommendations. Yeah, you're right. Sometimes some of these recommendations should come from IDEs. But one thing that I do notice is a lot of people are using IDEs less frequently. Like, they're using VS Code, they're using text editors. They would miss out on these findings if the developers chose to not use an IDE like PyCharm or JetBrains, series of IDEs or whatever. Like you can do profiling as a step. You can set up a code profile. You can there are some tools that give you code recommendations or do code reviews in real time within an IDE as well. But each of these things are things that the developer will have to think about, right? Rather than I've submitted my code and then automatically I'm going to get this back, right? I don't have to think about doing this as a step. I'm just going to get it back automatically as well, which is quite nice.
I think if you just take that last comment, Matt, and if you thought about like in a fictitious world, would it be nice to have a Code Guru plugin into like VS Code that as I'm typing, the machine learning model is happening as I see it? I think that would be a nice feature to see. Now, maybe that's not quite possible at the moment. Maybe it's not something that has come up. But I agree. Like I think as you were typing the code, that would be nice to be able to run that machine learning model over the top of your code as you were coding and be able to provide like in real time. That would again reduce that that time to market, and you would be seeing that as you moved along. Because a good example of that might be you've built this Python application that in 50 different places opens and closes a file. You don't really know about the best practice until you've committed that code. Whereas if you saw it in line, you would see that in the future. So I think that's a really, really interesting comment, and I think it could provide value in the future.
Well, I think we're going to see more and more of that stuff, like as IDEs and text editors evolve and cloud services grow, right? So that's something that I think will become a normal in the next couple of years as well. Looking at it, like there was another one from Shri. I'm just going to have a read of the comment. Code Guru after every change is made on any file.
Yeah,
review the whole application. Yep.
I'll answer that one right now. So Shri, this is exactly what we were doing before when I said, so I made that pull request. That pull request is the incremental code review. So that what was kicked off when I made the pull request. And this code review will only be looking at that specific one file. So it is incremental. And so the billing cost for this is about lines of code that it reviews, which means that if I was reviewing the whole repository each time, like it could be expensive, this will only provide the recommendations on the difference before and after the pull request. And so this is that specific example around that pull request that I just made. No, it wasn't here. It was here. So around this this specific pull request. And we can see here now that this has identified this is a Java application. We can see that it's identified a number of specific lines that have bad things in the code that it's saying, like, we should go ahead and change that for whatever reason. I will show that quickly how that works when you do a pull request. Because I linked to the repository as myself, it's not an organization-based repository, I linked it directly as myself. Code Guru will push those comments into GitHub or code commit. So now I can see those comments within GitHub itself. I don't necessarily need to go into Code Guru, and that could be handy if for whatever reason that team doesn't have access to the Code Guru service, or they don't want to do that. They want to stay within their standard environment, and pull requests happen through here. Like it's exposed and available for everybody. So if we were to look at which line is this specific comment here, I mean, it's difficult to see which line it is, but recommended Amazon code appears to be rating before resource before it runs. So I'm guessing that's probably this one. Yeah, it's this one here, right? So in event handler line 79, if I was to click that, it will take me directly to that line. So here it is. But if I was to look at the actual pull request itself, I can see that same comment has been placed over here. So it provides some recommendations around what you want to go ahead and do that. It also links to where that might be, so for more information. But also interestingly, it says you can leave feedback on this recommendation by replying to this comment or by reacting using emoji. I'm not exactly sure how it collects that data or what it's doing to do that, but I mean, you
can't do the thumbs up. We need like a rock, paper, and scissor, right?
Well, I can just do rocket, right?
You can only do
And so that's how you start to see this interact within your standard workflow. So you're seeing immediately I can see that, I can look into my code and see some things that might happen here. Let's have a look at this one. So here we go, using an outdated API. So this example is specifically around the Amazon SDK. So, says use list object v2, more performant. What's this one here? Okay, so again, it's looking, if you've got an S3 client, you've listed all the objects in a bucket. If you've worked with the list objects API within the S3, you know that it'll only provide you a paginated set of results. And that's fine if you've got 10 items in the bucket because you're going to get them all in one page. But if you had, 1,000, it's the listing of the files that you've got back from that is going to be not what you expect. So you'll constantly have files that have been left off that. And what about this one here? Okay, so I guess this is what it's saying when I talked about, understanding how Lambda works within the execution context. If you're creating a client builder, that's the instance of this method that is the instance that is going to be dealing with S3. If you're creating that within the execution context, you're going to be creating that every single time. Maybe think about making that a singleton, move it outside the execution context, declare it once, and then you can go ahead and reuse that later again and again. And that could save you some compute time rather than recreating that every single time. So these are some of the practices that it goes ahead and talks to you about. So I think that's a pretty good summary of how that works. I'll come back and think about, just look through some of the questions and then see if you've got any comments or any questions you want to ask, Matt.
No, I think today's been a pretty good session. I knew it was going to be a long one, so thanks to everyone that stuck around the extra 20 minutes or so. Feel free to fire off any extra questions that you've got in the chat too. But I think from my perspective, I just really like the fact that as a PR reviewer, if someone's submitted something, I can have an external system give me recommendations as well as to whether I accept that pull request or not. Because pull requests, are up, I guess they are subject to opinion sometimes, and humans make mistakes. And as a reviewer, and someone has given you 1,000 lines of code to review in a particular pull request, it can get quite overwhelming. Not that people should be doing that, but I think this really helps the reviewer, but also helps the person that's pushed the code. Right, they've got a series of recommendations they can implement. they can pull back their the PR and they can work on those recommendations and then put it back in for our evaluation too. Yeah.
So I think it's quite good. I think it's important to have like an unbiased third party to go ahead and review code. Another interesting use case that has come up is working with some of this within the education space. So if you were beginning your journey into a developer, or like even if I was back at uni, having somebody tell me what are good practices and why, you just learn from the get-go, right? Like, so you can say, run my code through this, Code Guru, and it tells me, I should go ahead and do that. And I would say that there'd be a lot of people that would do the exact mistake that we did by trusting that file handler is going to be closed at the end. We just don't think about those things happen. And you don't think about that until, a specific event happens on that server where, even if that machine was throwing exceptions and that exception was fine because it was looking for an image that didn't exist there, the application could crash because you've had thousands or millions of file pointers open. And that can be really difficult to go back and piece together what exactly has happened there. So looking for granular pieces like that is something that it's reasonable to assume a human might overlook something like that. Dashikan asked a question. Yeah. Can these review items be integrated into third-party issue trackers, such as how the commit message can be referenced? Like, we don't have anything like out of the box, like a connector that push that back into like, let's just say Jira or Trello or some sort of issue tracker like that. Not at the moment. However, like all of that information, it would be available to you. So you could pick that out and move through that and build something yourself. But as sort of Matt said, that this whole Code Guru service is really quite new as a service as a whole. And I know that even it was only like 3 months ago that Python came out as generally available. And it was only 2.5 weeks ago that the CI workflows came out with GitHub Actions. So I think it's really interesting that you make that comment exactly like that to say, I'd like to track that outcome in a third-party system and have those hooks between it. So, we listen to our customers, all the time, and I will directly take that and look, in our backlog and talk to the product teams about whether anybody else has asked that and how that might be or how they see that existing within the future. So that's a really interesting question. And I would say at the moment, I don't think there's anything native that can go ahead and do that for you. But I think it's quite valid because that would put it in a backlog of issues in your, let's just say, a Jira board. And then you could go ahead and address those bit by bit as part of your tech debt exercise within your software development lifecycle.
Yeah, completely agree.
So
yeah, Joshua Gunn's asking about JavaScript and Node. So
I would make no assumptions as to what we're going to release. I am not privy to what is coming out. What I can say is, like, I think a lot of customers will be asking for this.
Yeah, I've put some of my customers down on the list for JavaScript as well. But, there's a lot of languages that we could add. You've got like Go, C++, C#, C. It's going to take us a while to build a model for each of them. The model that we built was off a lot of the Java code that we had internally in AWS. If you read the documentation, it kind of mentions that, as well as some open source projects. We use a ton of languages at AWS. But we've got to consult those like different service teams and build models around them. And some languages that might be newer, we might need to find some added repos that we've reviewed and we can see the practices are quite right, that we can kind of take in as a good best practice. So yeah, I would love to see JavaScript, right? Because then I can test it out with my Amplify apps.
Yep. So yeah, I think it's it's a good service, and we've had a number of interesting questions. PHP would be a good one, right? Because I mean, so much of the world still runs on PHP, and for most people that have worked with PHP, there's like so much bad PHP out there as well. So I think that could be an interesting one. At some point, everyone's going to at least touch PHP. But going back to like all the interaction, the questions, we're fortunate enough that our stream has nobody after us, so we can go long if we need to. but we totally don't mind being completely derailed. We can always pick up again next week. It's, you know, the whole requirement of like us doing this segment is to help show some of the things that we are interested in or that the community are interested in, which is why we continually like look for feedback from people to say, what am I interested in, rather than us just, you know, thinking that what we think is interesting, which sometimes could be really interesting because we see like odd things sometimes. But yeah, we love hearing back from the audience and answering some of those questions, even if we don't know how to answer them this week. So Hello Lupin is after Lambda for PHP. So on AWS samples, there is custom runtimes for PHP and Lambda. And so there's a couple of examples around that. I've done a couple of videos on PHP in Lambda. So yeah, it is something that people actually use as a managed runtime. I don't know whether we'll ever see it, but it is very well supported with the Bref framework. And so if you are interested in that, go ahead and look at that. I don't necessarily think I don't necessarily think that PHP is a bad language. I just think it's because it's easy. Sometimes we find people move out of that space into an area that maybe like pays a little bit more money or something.
Yeah, it gets more and more. It's been like PHP 7 like has gotten more and more performance. You know, watching behind the scenes, I did a bit of PHP to start with. There's always a lot of money in WordPress sites and themes as well. So PHP is going to be around for a long time, but it actually is getting better and better and better since me using it 7 or 8 years ago. But the custom runtimes are really interesting as well. Like for Lambda, like I had a go with Swift, so Apple's iOS programming language. I had a go of having a Swift custom Lambda a couple of months ago just for fun. But you'll find that everything that's probably missing in Lambda in terms of like languages, we try and add as much as we can. You'll be able to set up as a custom runtime, and AWS will have some documentation around a blog or something that someone in AWS who's passionate about that language has gotten it to work with the custom runtimes.
Yep. Yeah, so I just pasted the PHP examples for running that. So you can run like full Laravel applications within Lambda. So it's quite interesting. Like 2 weeks ago, I did a demo for one of my customers that has some legacy in PHP. It's not overly complicated. They really want to avoid running any servers. They don't want to upskill to containerize it, but they just don't want any more EC2 servers running this. So I did the proof of concept again and worked through moving some of their application to PHP, and they were really happy. They just didn't know that it worked the way it works. And so yeah, it can be used.
Yeah, Laravel, I haven't even played with Laravel. I was CodeIgniter and Symfony, I think, back in the day. Like this is years ago. Yeah.
Yep. So yeah. All right, well, let's wrap it up for the week, and we'll actually, Matt, do you want to just post our Devs in the Shed YouTube video where you can go on our thing so anyone can subscribe? I got it.
Yep.
So anybody that wants to, go ahead and subscribe. Once we have 100 subscribers, we're able to customize the URL for our YouTube channel. We do impromptu streams through the week with things that interest us. And often they're something that might have interested us, or someone that on LinkedIn or internally that's asked us a question. Could you go a little bit further on that, or could you talk about this? We would love to dive into any of those suggestions. And I actually feel like maybe we'll do an impromptu PHP stream at some point in time.
Yeah. We did a little extra chalice last week, right? And the week before that, we used Pygame. So I've had a lot of Python-based stuff, but I'd love to like play with a bit of AppSync and Amplify, maybe Next.js. So yep. You do see videos pop up more often because the AWS Twitch schedule's quite booked out a lot of the time with content. So we kind of use YouTube for an avenue for uploading an archive of these sessions. We do stream live there as well, but it's our archival spot, but it's also like quick 5-minute session on X or 20-minute session on Y when we get excited in the evenings.
Or a 2-hour session on ECS Anywhere on a Raspberry Pi.
Yeah, that's right. The only issue is it's too cold at night when we usually do it that we're not in the sheds. So you'll see parts of our house. Yeah.
So yeah. All right. Well, thanks, Matt, and thanks everybody. Thanks so much for all the interaction this week. It makes it a lot of fun for us, and you also make us think really hard about what our customers are asking for, and provide valuable information to provide back to the service teams as well. So yeah, thanks for the subscription as well, Sheree. So thanks everybody, and we'll see you again next week.
Thanks everyone. Bye.
Take care. Bye.